So we just saw a simple method for measuring utility function under expected utility. It was, however, criticized by McCord de Neufville in 1986. They said, in reality, we are not in experimental heaven. Theories are violated to some extent, and we have to reckon with them and do our best to minimize the damage. Let us look at the stimuli of the standard gamma that we just saw. Here they are. McCord de Neufville said, these stimuli suffer from what can be called a certainty effect. Certainty effect means that people, subjects, have a special preference for certainty. They like it much more than risk. They have maybe emotional, irrational reasons to overvalue certainty. And maybe you now think, well, did we already see it? Because we had risk aversion and expected utility. That was a preference for certainty. And you are right there. But the thing is, the certainty, and McCord de Neufville know, and many people have shown, there is more to the certainty effect than expected utility can capture. There are components, emotional, irrational, beyond utility or anything, and experiments have shown, for instance, the Allais paradox. I will explain it later. The Allais paradox shows experimentally that the certainty effect is so strong that it gives violations of expected utility. Therefore, with this kind of stimuli, you have many violations of expected utility. McCord de Neufville said, maybe better not do it. They said, well, you should reckon with not being in the experimental heaven. The theory is not perfectly valid. Then better go to places where it is not violated so much, because then you get more valid, more consistent utility measurements. They propose an alternative stimuli, and I show you now. They're a bit complex, I will explain. The right lottery is 50-50 going up or down. If down, you just get M. If it's up, there's another lottery awaiting you. It's P1 minus P probability over the M's. Left prospect, it's either small m or alpha. So McCord de Neufville said, if here you still get utility of alpha is P. For instance, you can go to a subject and ask him, tell me which probability makes you indifferent. Whatever probability he says, that is the utility of alpha. So that looks still like the standard Gamble method. And it can be shown in algebra that indeed this is true under expected utility. I will one time quickly explain it in words, but at home you can read more slowly in a textbook how it works if you don't understand it now. Anyway, let us do the expected utility calculation. They are the same for these two. The lower branches give the same half times utility m for both expected utilities, so these cancel from the equality. So then we look at the upper branch. Here we have half times utility alpha. Here, using that integration, expected utility, they are linear in probability, in fact. But anyway, here we get half times the expected utility of that lottery. Now this common factor half, we can cancel it also. What remains is utility of alpha is the expected utility of that lottery. That's the same equality that we saw in the standard Gamble method before. And there we already did the algebra to show utility of alpha is P. So indeed, McCord de Neufville are right. This also gives you the utility in an easy way. The pro, well, I'm assuming that alpha is different than m, then there is no certainty effect. That's the big pro here. So therefore, we avoid one violation and we get higher validity. Probably you can also see that there's also a con to this method. That is that the stimuli are more complex, so subject may less understand, that may bring more noise. So in practice, which method is better depends on the situation, pros and cons. But surely this is a good alternative, and in many situations this is worthwhile. So it's good that they introduced it. Well, we can generalize a bit, and here are the stimuli. One thing we can generalize is the small m. We can replace it by any outcome capital C. It doesn't matter because it cancels from the equation anyhow. In fact, even more general, we can replace this by any lottery capital C. Any complex lottery, it doesn't matter because the expected utility contributions here cancel as long as C is common, the same. The C abbreviates common. So that's one generalization that's possible. Another generalization that is possible, the probability half can be any probability lambda. So let me put it up. Can be any probability lambda because whatever the lower branch is still canceling. In the upper branch, the common factor lambda cancels also, whatever it is. So indeed, here we have more flexibility of stimuli, and this is the more general method that McCord de Neufville proposed. Still, utility of alpha is P, that continues to be true, And now we can have many stimuli at our disposal. Now imagine, in practice, it's often wise, especially when you measure subjective preference parameters, because there's much noise, as is known in this field, it's wise to do several measurements and to compare them, take average and things like that. Imagine we do both the classical method. So this is the classical standard gamma method we saw in the previous recording. And you do the McCord and de Neufville method of measurement. You do both of them. Here you find P prime, here you find P. So here they suggest utility of alpha as P prime. This suggests utility of alpha as P. But now imagine that P prime is different than P. What do you think of the situation? What is going on here? What do you think is the utility of alpha? You can think about it for a while, stop the recording, and after you made up your mind, have some ideas, you can return. So I continue now. For one thing, we can already conclude expected utility is violated. Because expected utility says here, utility of alpha must be P prime. Here it says utility of alpha must be P, but that's a contradiction. P prime is different than P. We have a contradiction, a violation. The theory does not hold. Well, is that bad? Well, McCord de Neufville said, this is exactly our point. We say, oh, there are violations, because here the certainty effect is going on, and here not. And if it were not so, if always P would be P prime, then would be no use introducing our method. Then it would never give anything new, better stick with a simple existing method. But such discrepancies do exist. And then McCord de Neufville said, we think that our P is better than the traditional P prime, because that P prime suffers from the certainty effect, our P does not. Well, they are right in that, but the drawback is that their stimuli are more complex, there may be other noise. So in practice, if P or P prime is better, that depends on situations. But surely, as I already said, it's a valuable alternative, and in many situations, it is better. Now there's a change of story. I'm now going to continue to discuss the case from a normative perspective, but that is to be continued in the next recording.